Hello and welcome to Electronics 12. This is obviously a recap episode. I will point out here though that I was thinking of doing. I wanted to do some like animated stuff with the circuitry stuff. I will have to get going with that. I'm gonna have to just remind myself how to use screens and how to put the buttons on. But I do actually know how to do that, so it's just a case of forgetting it. Um, So yeah, there's not actually going to be any images here, which I would like to do, especially for this series. I'm going to have to use circuitry anyway, so it's kind of a case that I'm gonna start including images pretty soon. I think. What I've done here anyway is just done a review, and I've also included a little bit of kind of just research that I've done and things that I thought were quite interesting. Um, But yeah, I mean, I think the last couple of episodes actually were quite cool. So I would recommend watching those 9, 10, 11 as well. They were pretty cool episodes, and perhaps going to give something slightly different. Um, but yeah, uh, so if we want our electrons to flow in a certain direction to a certain location, the proper path must be provided for them to move in the same way. A plumber must install piping to transfer liquid to where they want it to flow. Um, so we're very much thinking about at this point. We're not thinking about circuitry yet. We're thinking about point A to point B, source to destination. So to do this, wires made of highly conductive materials such as copper or aluminium are used. Interestingly, actually, I believe, I think I was actually trying to do something. I was trying to look at this. There's a lot of interesting things with electron holes, and I was trying to think if I could somehow include that into this bit here, but I decided against it in the end. But there's some interesting analogies, and obviously there's some analogies here with the piping system and the marble things I've talked about as well. So analogies are actually very, very important. They help to make what is fairly drab text more interesting, I suppose. Um, and yeah, so I'll certainly be looking for more and more analogies, and that will possibly mean I have to try to do some more artistic stuff as well. Um, but yeah, I mean, it'll my artistic stuff is I don't know. It's hard to say what it is. I would say it's not terrible, but it's close to terrible. Well, sometimes it can be quite cool actually. I don't know. It's different. So anyway, but yeah, interestingly as well. Another thing I thought about that. Obviously, there's a parking garage. Yeah, there's a thing with electron holes. There's a parking garage rather, and there's the auditorium issue. But I thought this electron hole issue looks a bit, this advanced fucking PN semiconductor stuff is a bit too advanced, really. Seeing as I'm right at the beginning almost of this course at the moment, or this, well, it was not really a course. It's just me talking about electronics, really. But anyway, so yeah, so another thing I thought about here actually was that highly conductive materials. Um, although they're good, these materials, it's only when you compare it to like non-precious metals. I believe that diamonds are better. You would think anyway. Um, but yeah. All right, so copper is the highest. That's actually I did say, didn't I? I did put it in. As the highest electrical conductivity rating of all non-precious metals. And then this is actually something I'm going to be talking about in chemistry. I haven't got into yet. The copper atom, the atom is 4s energy zone or conduction band. It's half filled. So obviously it's this is the thing, isn't it? Like, yeah, I need to study more chemistry as well. Really, luckily, I'm trying to do a bit more chemistry study at the moment, just to and I should really do, really get a grip on the valency stuff and all that stuff, and obviously this stuff is to do with the orbitals. Um, so the more I visualize this stuff, I suppose with that stuff, I'd probably have to do some 3D stuff. I've not really done that much 3D stuff. Uh, so I don't know though. I may have to look into that. There are probably some interesting solutions I could use for that. Um, we'll see how I decide to do it. It may get to the point where I do have to start um, thinking about trying to change the way I do things. But at the end of the day, I'm not too concerned really. Um, I think all that stuff will come. I'm well aware of all the different things that are around. So it's just a case of trying to incorporate it. And luckily, I'm still quite an early stage here, so it doesn't matter too much. But yeah, so look around the atmosphere's energy zones half fields, many electrons able to carry electric current. Like I say, it's not all included in what I actually said in the previous episode. It's just a bit of stuff I was looking up. When electric field is applied to a copper wire, the conduction of electrons accelerates towards. So we haven't even spoken about electric field yet. So again, I'm getting ahead of myself here, but I just thought it was interesting just to look at this term. I'm kind of interested in this issue of positive and negative. I'm trying to think of some kind of what is this? What is the sort of tactile sense of positive and negative? That's kind of what I've been thinking about. But when a field is applied to a wire, the conduction of electrons accelerates towards the electropositive end, thereby creating a current. An electropositive, and funnily enough, when you look at it, if you type in electropositivity, you'll find it just goes straight to electronegativity, and there's loads about that. But electropositive has got small sections that's apparently only used for shark repellent when immersed in an electrolyte. It said seawater, and I was thinking maybe seawater is the same as dirty water, because I did actually cover that. I did actually talk about that, I think, much earlier on. Because when I was talking about, because if you recall, when I was talking about, this would have been in Electronics 5 now, I was talking about, conductors, dirty water, and pure water. And this whole electrolyte thing, something I remember from chemistry as well. I thought it was quite interesting. This idea of the methods used on shark repellents, and obviously you got these images of wires hanging down in water, and then and the whole water being electrified. So it's obviously a cool thing there. The greater the metallic character of an element, the greater the electropositivity. Therefore, the alkali metals are most electropositive of all. That's interesting, isn't it? I mean, again, it's a bit more chemistry thinking, but interesting. The more metallic, how metal is this element? That's quite a cool way of looking at it. And so it's basically saying the alkali ones are the best. And I believe that's alkali metals is potassium, sodium, rubidium, maybe. Is that even an element? I might just be wrong on that. Lithium, I think. But they're cool though, those elements. I like the way they look, to be honest. I've always thought those elements were quite cool. So, so they're the ones that are the most positive, electropositive. It's a bit of a strange way of looking at it, but I suppose, sometimes, at the end of the day, it's like sometimes you're a certain way. Sometimes you feel a certain way, sometimes you feel in a certain different way. So, they all add to the experience, I suppose. Alright, so electrons can flow only when they have the opportunity to move in space between the atoms of a material. That was actually why I thought they were doing the parking garage electron hole thing. I think they're all just moving. It's all just electron holes, really. That's just so weird to think that, the whole space is just nothing. So yeah, but then you're hearing about this continuous path, but in fact, it's not really continuous. It's interesting dichotomy, isn't it? So this means there must exist a continuous path of conductive material providing a conduit for electrons to travel through. But yeah, I mean, fundamentally, what I'm saying, what I've been saying here is not particularly difficult. It's why I didn't write too much here, because basically I did say kind of the same thing a few times in a row, but. Again, it's good to see it here. So there's continuous path of conductive material providing a conduit for electrons to travel through. So as long as you've got a wire, so and at this point I was thinking, obviously, just thinking of this straight wire sort of thing. So and then with the marbles, of course, I've spoken about marbles a lot. marble, you put one marble in left hand side, push it through, the ones come out on the side. Of course, that's only going to happen if and only if the tube is open on the right hand side. I'm not quite sure where these dashes have come in actually. I don't actually like them. I don't know why I've been putting them in. I was just thinking, why am I fucking putting these dashes in? It's just stupid. You know, because eventually eventually you probably want to abbreviate it to LHS all capitalised anyway. There's no fucking point doing that. But yeah, so that's the thing. So the marbles flow into the left, and if only if the tube is open on the right hand side. Otherwise, it's just gonna sort of bang together and then stop. All right. Well, they could pile up inside the tube. I suppose if the tube is not malleable, then they won't. Then it's just stop. But yeah, maybe if the tube is a malleable, made out of some kind of sort of slug type, biological matter, then maybe. All right. Don't know what's thinking there, but anyway, so the marble flow is not going to occur if that's not the case. The same is true for electric current. Continuous flow of electrons requires to be an unbroken path to provide that flow. So you need that unbroken path. Otherwise, the flow is not going to occur. There is something a bit funny though about what's going to happen next. And this is where I actually did some of the pictures. But to be honest, I explained the pictures. I thought, I may as well explain the pictures as well as draw them. I mean, well, I'm not going to draw them, so I haven't got to really. So a thin solid line is a conventional symbol for a length of a wire. Because there needs to be continuous flow of electrons within the wire, there must be a hypothetical source and a hypothetical destination. Okay, so we want this continuous flow. You can imagine electron source on the left-hand side, pushing electrons through the wire to the electron destination on the right-hand side. So you can imagine there's the source, and we're not going to explore the motivation for how this source is pushing it. But we're just going to make that assumption. This source is magically fucking pushing it to the right-hand side. So the source is pushing it and to the right-hand side. Of course, so if there's a gap in the wire, there's going to be no flow because it's going to push it and then but it's not going to push it, is it? That's the thing. It's not actually going to push it. It's not going to push it and then go down into the hole. It's just not going to push it at all because it's based on that continuous aspect. It's like as soon as it's like fucking microns. Well, may as well. Microns not that small. If it's like microns away, nothing's going to happen. As soon as that connection's made, boom, the whole lot just goes up. So that's a good way to look at it. So electrical source on the left hand side, pushing electrons through the wire. There's a gap. There's going to be no flow on either side because there is an insulating material. So if you've got a water pipe, you cut it too, you cap off the broken ends. There's not going to be a flow. It's not going to fucking teleport across. Anyway, so we know flow of the nearest pipe to the furthest pipe. So that liquid is not going to go. And in terms of electrical conductivity, the condition of electrical continuity is false, therefore there's no flow. So there's no fucking, no fucking, well, it might be discrete things actually. But yeah, we'll just assume, I don't know. So there's a break in the wire. Here we are. This bit was the more complicated picture. This one is weird though. Because this is saying you could just fucking force it through anyway, even if there isn't a circuit. Yeah, so there's a break in a wire, but another piece of wire is appended to the initial wire before the break and connected in a continuous way to the other side of the wire, i.e. after the break. So you've got a wire coming in, and then there's a break. But just before that break, you've got a ball that's connected, a metal-to-metal contact ball that's connecting it down, and then it comes up. So there's the break. So so it's basically to the right-hand side of the break, but it's also to so on the left-hand side of that, you've got a bit of wire that was broken to the initial wire, and then the right-hand side is the initial wire, the end of the initial wire, and then it just flows in. It makes that continuous connection basically. So yeah, so how did I put it? Another piece of wire was appended to the initial wire before the break and connects a continuous way to the other side of the wire, i.e. after the break. And once again, electron flow would occur. There would be a metal-to-metal continuous pathway for electrons to flow from source to destination. So the electrons are flowing all the way from source to destination. So there is it's going from one all the way across. Even though there's this break here, the broken section on the initial wire to the right of the break and to the left of the newly formed connection will have no reflection of the. That was the perfect way to put it, actually. It's not part of the source destination pathway. But it's interesting, though. It's interesting. It still flows. So it still flows, even though it's not kind of part of the. So it's an interesting sort of thing that. So it's not. So it's. I mean, I found that pretty interesting, actually. And there is, and it does seem to be a difference with regards to a circuit. I wonder if that's just a hypothetical thing there. To be honest, though, I have a feeling that is actually irrelevant. This whole section, the section I just said, was kind of irrelevant. But it's sort of like this sort of thing which is interesting to know, anyway. Because you always, well, at the end of the day, it's going to be circuits from here on, really. Let's be honest. So, all right. So no wear occurs within wires. The electrons do encounter friction and generate heat in a conductor. I actually thought I was looking up electromigration here. Electromigration is a pretty cool thing, actually. It just say there's wear until within, ICs and stuff like this. What is I can't remember what IC means now. Interconnected circuit, maybe. Sorry, I can't remember what it means. But the point is, when you get very, very small like groups of these transistor stuff, the electrons actually can decay. But that wasn't really what this was going on about. This is nowhere close within wires, although the electrons do encounter friction and generate heat in a conductor. So it was interesting. Of course, we're not going to go into like the first law and all this stuff. Anyway, conductive materials such as copper, I probably did do that before. The outer electrons can move around easily and are called free electrons. So yeah, that's all I said before. If it's 4s, got plenty of free electrons, nice conductivity ability. Insulating materials, the outer electrons are not so free to move. And then this is almost going back to the start, really. Dynamic electricity is uniform motion of electrons through a conductor, and static electricity. This is actually a better way of saying it, though. Is accumulated charge formed by an excess or deficiency of electrons in an object formed by charge separation by contact and separation of dissimilar materials. Alright, so I won't dwell on that too much. And then the question arises how electrons can flow continuously without both source and destination having infinite capacitance. And then the answer lies, of course, within the circuit. And it's a never-ending loop pathway for the electrons to continuously flow around, and the basis of most of electronics, yeah. So this is the only way to have a loop pathway. Otherwise, we'll be constantly dipping into the source bucket and pouring into the destination bucket. All right. So with circuits, there can be no breaks in the wires. So this circuit seems to be. I mean, yeah. I think circuits seem to make more sense than this just going from this point to point. This idea of point. I think perhaps that was what I was talking about. Point to point charge. You always hear about this word point, which is actually a hypothetical word. But yeah, well, you say point charge, don't you? Remember when I was looking at electrons? What is a point charge? Trying to get it in it is sort of like a lowest common term thing. Okay. So with circuits, no breaks. Otherwise, if there's any breaks, there's no flow in the whole circuit. So that's straightforward. Electron pushes on the one in front of it. It turns this electron pushes on the one in front of it, and that's similar to what we saw. If we've got the marbles in a circle, that's what the picture I drew there. Circle inside a hula hoop. And there was also the picture of the electrons just going round and round, each one pushing on the one in front. So yeah. I suppose it's a bit like dominoes if the dominoes never fall over and they're in a circle. That's interesting, isn't it, to think of it like that? I mean, I know there's a lot. I mean, obviously, I've looked at this stuff. I know the domino thing is quite important in nanotechnology. I just happen to know that. It's interesting. We've got one domino goes over, and then it doesn't. But at the same time, we'd have to sort of like, what it would do is it would go over, wouldn't it? And then it would sort of, but instead of just pushing it over, what it would do, the domino, it would jump in the air, and then it would sort of lunge forward, pushing over the one in front, and then land completely, and before it lands, it would gather, it would go its center of gravity. But the problem is that the other domino that it pushed, that one would jump in the air,